This problem, number 4 on the exam, is about the kinetic energy due to a current loop in a uniform magnetic field. We know that the maximum kinetic energy is going to occur when the moment arm is at an angle of 0 degrees with the magnetic field, and we know that the moment arm initially points out and to the left, up and to the left, because if we curl our fingers in the direction of the current loop, our thumb points up and to the left. The moment is given by the number of turns in the loop times the current times the area of the loop, and the energy is given by minus moment times the magnetic field, B times the cosine of the angle between the moment and the magnetic field. So for our particular case, we have a moment of 5.6 amps times meters squared, and using this number, we can calculate our initial energy to be minus 5.6 times 2 the magnetic field strength times the cosine of 115, which is the angle between the initial moment arm and the magnetic field. We get 4.73 joules initially, and the final potential energy is going to be equal to the moment times 2 times the cosine of 0, so minus 11.2 joules finally. And then we use conservation of energy, initial potential plus kinetic initial energy equals the final potential and kinetic energies, and we know the initial kinetic energy is 0, so we can calculate the final kinetic energy to be U initial minus U final, which we get 4.73 minus a negative 11.2 or 15.93 joules, or about 16 joules, and that's the maximum kinetic energy this loop attains during its motion. This is because the torque on a current loop in a uniform magnetic field always tries to turn the loop to an angle of 0, because that's where the potential energy is the least. So that's why it turns the way it does. Thanks.